Today we are going to be walking through the new Cursorless pnpm Typescript monorepo setup. We have a few people here watching who will be interrupting with questions as and when I confuse. The first question to answer is, what is a monorepo? So I think probably the easiest way to understand a monorepo is by what it's not. So it's kind of in the middle of a spectrum. And again, please, people who are listening, correct me if I totally butcher what a monorepo is. But my understanding is that on one end of the spectrum, you have what's called a monolith. And on the other end of the spectrum, you have multiple repositories, right? And so multiple repositories. So the core thing is that you need to deploy multiple things. That's the problem that we're trying to solve, okay? And so with a monolith, you can, just deploy one thing often with a monolith, right? And so everything is just in one repo. Any package can import any other package. Everything just directly talks to each other, etc. Whereas on the other hand, if you're deploying multiple things, like microservices is kind of the common thing that people think of. In Cursorless, it's not. In Cursorless, we have a website. We have the docs site, which is built separately from the website and just kind of bundled in there. We have the Cursorless extension in VS Code. We have the Talon side of Cursorless, but that we're not really counting that today because that's just Python Talon side. There's another video about how that gets deployed, which I'll publish sometime soon. And then in addition to the Cursorless extension, today that basically is it. There's also the cheat sheet, which gets bundled into the Cursorless extension, but actually first goes through an HTML processing, React, etc., and turns into a single page bundle, which goes in the extension. So that's sort of like 4 endpoints. And the thing that actually pushed us in this direction mostly is that we want more endpoints, right? So we want to be able to run Cursorless in a browser in vscode.dev. We want to be able to run Cursorless in JetBrains editors like IntelliJ or PyCharm. We want to be able to run Cursorless in Emacs. in Emacs, we want to be able to run it in Vim, etc. Right? And so we basically need to publish Cursorless as a LSP, a language server, and then we'll have a version of the VS Code extension at the start, which will go through the client, right? And then another version of the extension which just bundles it in directly at the start. So the point is, we have a lot of different endpoints where we need to publish things. One way to do that is to have multiple repos, right? And that's sort of the other end of the spectrum from a monolith. Is each of those different things would have a repo. We'd have our website, we'd have our docs subsite, we would have our Cursorless VS Code extension, we would have our Python side, we would have all of these different things would be different repos. And the problem with that sort of setup is code sharing, right? So like even simple things, like I have some like common libraries that I tend to use or things like that. How do you share that code? But we want to share much more interesting things. We want to literally be able to run the Cursorless engine from within the website, so you can do live interactions as you're learning how to use Cursorless, right? We want to be able to show you the test cases and have our 2,000 test cases, 3,000 test cases become part of the documentation, right? And also the Cursorless core engine itself, we wanted that same engine to be used both in the website, in vscode.dev, in the Cursorless extension that runs in VS Code, in the language server protocol without rewriting things. Now, you can do that with multiple repos, but then you end up in a situation where you basically take each of you take the shared code, you factor it out, put it in a separate repo, but then how do you now make sure that you don't break something, right? Is one problem, right? Like, how do I make sure that in CI, like continuous integration testing, regression testing, how do I make sure that I make a change in like, some library that I use in 5 different repos, make sure it doesn't break before I publish, right? In addition, we're obsessed with developer experience, DX, right? And that is, obviously Cursorless is fundamentally a DX tool. Obviously, you can use it for things that are not developing, but like at the end of the day, the reason that I started working Cursorless in the first place is because I want to make development easier. And so that obsession extends to developing Cursorless. We want the developer experience to be phenomenal when you're working on Cursorless. It's selfish in part because I spend all my time working on Cursorless, but we do want to make it very easy. And so one of the things that we really like that we're getting from this monorepo setup is we kind of get the best of both worlds. So on the one hand, we get very proper isolation between the different packages, right? So for example, when we were taking Cursorless and trying to make it so, look, Cursorless before, when Cursorless was first developed, it never occurred to me that it would ever exist outside of VS Code. And so just with impunity, while we were developing this stuff, we would just import VS Code anywhere, everywhere. Who cares? And then, people came along and they say like, hey, apparently there's all these other editors out there. And so what we needed to do is basically build an abstraction that wraps VS Code and then stop referring directly to VS Code from the core of our code base and basically put all of that VS Code stuff behind this abstraction. But we want to make sure that once we've done that, we don't then, because then there's this sort of lag time where, okay, we've done that, but now we haven't yet started using Cursorless outside of VS Code. How do we make sure that we don't, without realizing it, start to import VS Code? You can do it with lint rules, and it's what we did for a couple months. But first of all, the lint rules are really, really ugly. Second of all, auto import gets messed up because auto import doesn't respect lint rules. So that's one thing, right? So on the one hand, we want proper separation between packages. If I'm within the core Cursorless engine, I shouldn't be importing VS Code. I shouldn't be importing any other packages which do import VS Code, right? So we want very strict separation between packages. However, we kind of want the flip side of that as well, which is to say, okay, this package imports the Cursorless engine, right? So the Cursorless engine shouldn't be able to touch anything that imports VS Code. But on the other hand, the VS Code extension itself imports Cursorless and imports VS Code stuff. Well, I want to be able to do things like, say, find references or rename across packages, right? So if we decide we don't like the name of some type or some function in the Cursorless common, which gets imported in 5 different packages, I want to be able to just say rename air, say something, clap, and it just gets updated everywhere across our entire monorepo. Across those package boundaries, right? So on the one hand, we want very, very clean separation when we want it, and we want perfect seamless integration when we want that as well. And so that's basically the reason to move to a monorepo, right? So it's basically to be able to, and also CI becomes very easy because everything is a single version. We have the same version of all our dependencies across all of our packages. And so in CI, I can say, all right, I make some change to common. It's pulled in by 5 different endpoints. Well, we have a test which tests our website. We have a test which tests Cursorless extension, tests for blah, blah, blah. And if we break something, then CI will pick that up. So we can't break the website accidentally. It's just one single SHA represents the state of the entire Cursorless universe. I'll pause because that was kind of a monorepo monologue. Any questions?
Why doesn't everybody use monorepos?
Yeah, that's a good question. So I think, getting the tooling right was really hard. And it's also fairly recent that the tooling even exists. So like TypeScript support for monorepos only shipped within the past 1 to 2 or so years, maybe a little more than that, but not a lot. And so it's still fairly new, and the tooling is like, there's a bunch of different approaches. So like the long story short is there's some overhead to get set up. And it's not really justified if your project is not that small, or if you don't have multiple endpoints. The isolation can be nice because you can get but like if it's a 1-person project, you have a single endpoint. I'm not sure what the point would be. But
if you have one application and many libraries, if you can just unit test all those libraries and they are only consumed from in a single direction, then you don't really need this. The point of the Cursorless monorepo is that we have multiple packages. Some of them talk to each other across, and some are not allowed. And that kind of like fine control is what Pokey has busted his ass to achieve.
Yeah. And I guess
I mean, it's definitely not easy to set up.
and I guess the other, so on the other direction, I said on one side, you're too small for a monorepo, right? And then on the other side, if you get even bigger, the tooling gets even more complex, right? Because now you start to have like such a gigantic Git, because it's one single Git repo, right? So the Git tooling has only started to catch up to do things like, shallow clones and like checking out a subset of the files, all that sort of stuff has only existed in Git in the past few years. And so that sort of as you scale, the tooling is complex, and as you scale down, the tooling is complex. But there's a lot of benefits. So far, the Cursorless monorepo, TypeScript wise, has only existed for a week or so, but so far I'm loving the DX. I don't know about the other people who are developing on it, but I think it's been pretty seamless. But correct me if I'm wrong.
So far,
and I'm sure
so
you'll
good.
cover this, but which TypeScript features needed to exist to support monorepos?
Yeah, so it's called composite and references, and I'll get into that in RTS configs. But those are the two flags.
Okay.
Yeah, they're called package references, basically. So cool. Yeah, so I mentioned that there are some things that we wanted out of this. These are what I call the desiderata. And so I'll give you a quick glimpse of those just so you can get a sense of the sort of things that we were trying to accomplish with this. Yeah, I know. So let's see, where is it? Coder. Portal. Open Cursorless polls.
Attention to all the questions about audio setup.
Drowse. Yeah, exactly. But no, totally seamless. All right, so let's see. Let's look for closed issues. And let's see, where is it? It shipped not that long ago. And as you can see, we didn't get it right immediately. There was a few fix this, fix that sort of PRs before we were happy with it. So there we go. So this is the big PR that does it. And as you can see, these are the desiderata, right? And so all these things, like, okay, if you import something that you don't want, like, you shouldn't be able to import things that you don't want. You should be able to import the things that you do. Local packages, using being able to use aliases versus relative, and then auto import, right? Because that for us is huge. Andreas and I both use a command which is called imports fix, where basically, you copy and paste some code from one file to another, and you just say imports fix, and it just automatically imports automatically does the importing. And if you're careful enough and narrow enough with what you export in various places, that just works, and it's a beautiful thing. You never have to worry about imports. But like, if you're not careful, then like, okay, I automatically, we have something called text editor. VS Code is something called text editor. And for a while, before we were on this proper monorepo, you would say imports fix, and you'd pull in the VS Code text editor, right? So without even like trying.
For some reason, TypeScript prefers VS Code's own definitions, even if they are, far away, use-wise or structure-wise, or
it just prefer,
This is just that classic Microsoft monopolistic behavior is what it is.
Definitely.
Yeah, the regulators will break it up, but until then, we have monorepos. Cool. So this is kind of our desiderata, and then all these things, right? Renaming, jumping to definition across projects, stuff like that. And so, as you can see, we pretty much hit all of them, which I didn't think would be possible, but we eventually got there, and it works quite nicely. Some of these checkboxes that aren't this, I'm tempted to make a TypeScript plugin for. So far, I have held off getting nerd sniped on that, but basically this is the biggest issue which bugs me, and if we have time, I'll show you guys why that is annoying.
I'm going to do quite a few file util things in my own extension, so if there's something you could add on top of that,
yeah, it's going to need to be a TypeScript server plugin to make this work.
Okay, it's going to need to be that involved. Got it.
Yeah, but it's actually looks like it'll be surprisingly easy to do, but I've managed to stop myself from doing it so far. Right. Okay. Cool. So let's So yeah, we decided to use pnpm for our monorepos, right? So like TypeScript, you need to configure TypeScript monorepo wise, right? To make sure the TypeScript knows you're a monorepo, and then you need your package manager to know you're a monorepo, right? Those are sort of the two pieces. There are setups which try to handle them in tandem. So NX, for example, tries to do that. We ended up bailing on NX because it introduces a lot of boilerplate, like a lot of boilerplate. If you look at this PR, we shed 24,000 lines. So that was kind of a win. And a lot of those lines of code, neither Andreas nor I ever read because they were just generated by NX, which is not a great feeling.
Yeah, when NX adds like 4 or 5 different dot files, and they do that in a dozen different directories all over the place. It's for,
Yeah, and 4 or 5 is sort of a best case scenario.
So Book has achieved the same thing with way less configuration, which is nice.
Yeah, we have basically 2 config files that need to be in each package: tsconfig.json and package.json, and they're mostly automatically generated. But they're small. So yeah, and the other thing about NX is there was just a couple bad smells, like a couple issues which were longstanding open, which the maintainers never responded to. Like it almost seemed like the maintainers didn't even know the issues existed, and they were fairly fundamental DX things, like breakpoints in a Next app, which is like breakpoints in a Next app in VS Code is like. That seems pretty basic, right? Like the number of developers who must be using NX to do a Next app in VS Code is probably a lot. And the fact that there wasn't even a single maintainer comment on there, and there was a couple others like that where it was just a really weird smell, where it's like,
sorry, what's the Next app?
Next.js is like one of the most widely used JavaScript web development frameworks.
Using Next.js. Okay.
Yeah, sorry, Next.js. Yeah.
And also now we don't actually rely on some third party. Now it's pnpm and TypeScript, and that's it. We are actually relying on core features of the package manager.
Well, to be fair, pnpm is kind of third party to the system, right? Because it's not npm. We looked at npm.
Yeah.
I'll talk about why we didn't use npm, but yeah, but pnpm is smaller.
pnpm is basically just the understanding of modules on top of npm, kinda.
Like souped up
compared
npm.
to NX, that is this like gigantic framework that's going to do everything for you, that has like caching and documentation and all of that. And now we have this separation of concern for our dependencies, which is kind of nice.
The other problem with NX is that they have all these generators, but the problem is you get this weird sort of cross-product thing where it's like you can't just use you can't easily just say like, hey, I want to build a Next app, or like now I want to build a Remix app instead of Next, right? You need to wait for NX to build their own skeleton, for their own scaffolding generator for that new technology. So it's like you can't really be on the bleeding edge. You kind of have to be on their version of it. So for all those reasons, it just felt too heavy. So that's why we didn't go with NX.
I didn't realize that it looks like you actually did move to NX and then you moved to pnpm. I thought
we
NX
moved
was sort of abandoned.
The website and the docs site and the cheat sheet were NX. The rest of Cursorless was not. And the plan was to migrate the rest of Cursorless into the NX subdirectory. So we just had a NX subdirectory that was going to become the root directory and eat everything else. And eventually that didn't happen. So yeah, we used it for a couple things. But even those small things, as you can see.
Wow. Even those small pieces gave you the 20K.
And most of these lines, a lot of these lines are lock files, for to be fair. But yeah, long story short, we got rid of a lot of boilerplate.
Because pnpm only has a single log file, right?
Yes, one lock file, which is nice.
Yeah.
Okay, cool. So we ended up going with pnpm. So yeah, another thing to talk about is why pnpm versus npm. Because the original thing we started to move away from NX was to say, look, let's just use npm, because they do have a notion of workspaces. And actually, this developer who comes to these meetups was the one who sort of pushed us away from npm and towards pnpm. And there's a couple, and so the main reason for that, the most convincing reason for me, was that pnpm doesn't do hoisting. Okay, and so what you need to understand is the way that autocomplete works in VS Code. autocomplete in VS Code is primarily based on node modules, right? So when you do an npm install or a yarn install or a pnpm install, what that does is it takes your package.json, coder, drowse. It takes the dependencies which are listed in your package.json, right? And it will go and do version, like resolution, etc., and construct a directory called node modules. Okay, and that basically has subdirectories for each of these different packages, right? And so when you do autocomplete, right? So let's say list doc, pick 6, drink, proud text, drowse, right? So when I do autocomplete here, right? The TypeScript server, the TypeScript language server, okay, which is part of the TypeScript monorepo. So the TypeScript itself is a monorepo, right? And so the TypeScript language server is what's responsible for these autocompletions. VS Code just leverages that. And the way that it decides what it should be proposing to you is that it will primarily look in your node modules folder. Now that's, there are some exceptions to that rule, but that's primarily the bread and butter of where these suggestions are coming from, okay? It doesn't just look in the node modules of like the nearest node module containing your file. It actually keeps walking up the chain looking for parent and parent and parent node modules, okay? For one, but basically even without that behavior, what npm does, even in a monorepo, is what's called hoisting. You get a single node modules directory at the root of your monorepo, which means
with pnpm.
Say again.
With pnpm, you mean?
With npm. So with npm, you get hoisting, which means that you'll get one node modules at the root of your monorepo. Okay.
Oh yeah, if you use workspaces, you mean?
If you use workspaces, right? So yeah, workspace is right. So workspace is the npm and pnpm term for monorepo. Okay. That's what they call them. So in TypeScript, I believe they call it a project. In pnpm and npm, they call it a workspace. I call it a monorepo. So you hear those things, they're synonymous. And so the point is, if you use an npm workspace, even if you have 7 different packages in subdirectories, all of the dependencies are going up into the same node modules folder. And what that means is that when you do your auto imports, it's going to just give you the world, right? So notice here, I'm in the engine, in the Cursorless engine, I'm in common, right? Which is imported by the Cursorless engine. I don't want anything from VS Code coming in here. That would be a nightmare, right? Because then you'd say auto import, and then sure, we'd have a lint rule, but by that time it's annoying. It's like, why did you give it to me if I can't have it, right? So we don't want things coming into your auto import that you don't want, right? So the
problem is that everything gets hoisted to the root, and
exactly.
Since TypeScript looks for node modules in all the way to the root, basically every single file is going to have every single import,
Yeah. So that was just okay, cool, showstopper, right? PNPM does things differently. PNPM is a really interesting setup, and I could probably take the whole hour just talking about PNPM, so I won't go into too much detail. I'll just say that the way things work in PNPM is each package, right? So as you can see, probably we're showing this now, right? So this is the root of the Cursorless monorepo, and most of the action happens here in packages, okay? So these are the different packages. And as you can see, we may do some restructuring. Some of them are endpoints, they deploy, and some of them are actually just libraries, right? So Cursorless VS Code, that is the Cursorless VS Code extension. That's an endpoint, right? An app of sorts, right? Another endpoint which we deploy from. So the Cursorless cheat sheet local, that's kind of like an endpoint that basically bundles up the cheat sheet into an HTML file, which then goes into the Cursorless extension. So it behaves like an endpoint. There's cursorless.org, cursorless.org docs, right? And so these are basically the like primary endpoints. This one, this one, this one, and this one, right? And then we have all these packages which get imported, and we have like a test harness, etc. And so if you look within each of these packages, right, you can see each one has a node modules, right? It's grayed out because this get ignored. But you can see they each have their own node modules. And within each node modules, you can see they only have the things which are coming from their package.json. So there's one more node module. There is still a root level node modules, okay? And this root level node modules is here. And as you can see, we're getting a few things here, but they're all kind of coming from here. And basically, so these can get imported, but they don't really export too much, and they're kind of used everywhere. They're very scripty things. But long story short, you get these node modules in each directory. It does some really fun things where these are actually symlinks to there's a root level directory of all the different packages of all the different versions, and these actually get symlinked. So it's super efficient with hard drive space. Installs are like lightning fast. And
when
so,
you say root, you don't mean the project root, you mean like the root on your disk.
So there's this little place called .pnpm here, and so you can see these are all the different packages and all the versions that you're using.
Okay, so it is per repository.
Yes, so basically
per monorepo.
Yeah, so everything in your node modules is a symlink to one of these directories. However, I think what you're thinking of, Andreas, is that they're the files within here are actually hard links to a root level blob storage, content addressable blob storage that that pnpm uses at the root of your somewhere, like, in your user directory, I think. So that
so that means if you use the same dependency in multiple totally separate projects, you don't actually have to download them. Kind of similar to how Maven works on Java, where you have in your user directory this master repository.
Yeah, and the cool thing is it's on a file by file basis. So if let's say you bump a version of, you use two slightly different versions of something in two different repos or whatever, then basically if they only differ by one file, you're going to be hitting the same. There's like, you only get the diff in terms of like difference in your content storage, which is kind of cool. So there's like, this will be,
I mean, that is my main gripe with npm, that you basically have to download the world every time you make a new application.
Yeah,
and
exactly.
you kind of use, like, how many times have you downloaded Typescript?
Yeah, and I will say, just broadly speaking, pnpm has a fairly nice feel to it. It just feels like they've spent a fair amount of time trying to make the DX nice. They have some really cool things they've picked up from other places. Like there's this really awesome, I'm going to get rid of this because I'm going to forget otherwise. Cross. Nope. Disk. Drowse. Okay. I'm paranoid about leaving random things in my files because I've done it so many times. So if you look at they have this really cool thing called like patches. So like we have to patch one of our dependencies to tweak the way search works on our docs site. And like, there's just a command. You just say like pnpm patch and then the package name. It'll create a directory for you. You can just say code and then the name of the directory to like pop that open, make whatever changes you want, save them, go back to your monorepo, say pnpm like record patch or whatever, and then it just does it. It puts it in here, and then it like puts it in here. Here's the patch. Here's where you can find it, blah, blah, blah. Super slick stuff like that. And like, really cool rules around peer dependencies. Like I wanted to override so we can use React 18 with DocuSource because it just works, but it's not a peer dependency. And instead of just like completely disabling peer dependency check-in, you have some really nice things. So it's just like, it feels like
in a patch, like you are actually using a published dependency, but you're applying your changes to it. So you don't actually have to fork it.
Exactly. Yeah. And so like, we're trying to get these changes in, but in the meantime, we have just patched one of our third-party dependencies. But long story short, the main point I'm trying to make is that like I really get a good. It smells good to use the same sort of simile that I was using with NX, like a bad smell. There's a lot of good smells with pnpm. It just feels like a repo where they've really paid attention to DX or a project. So far we're quite happy with it. Okay, so that
it means you can actually use pnpm even without the monorepo because it actually has other benefits.
Exactly. Yeah, exactly. You get this efficiency around like the symlinks and that sort of the hard links, the symlinks. It's faster to install. We have all these like cool patching things, nice ways to do peer dependency rules, stuff like that. So while this is staring me in the face, there is this field called package manager within your package.json, and it's a good idea to use that to just indicate, look, this is the package manager that you should be using. Because someone in theory, especially if you're not a monorepo, they could just try to npm install, but this is a way of saying like, look, this is what we want to use. By default, no one listens to this, but there is something called CorePack, which is like an NPM experimental module or a Node experimental module, which makes it so that you can just use that and it will respect this and just use whatever the repo maintainers want. But
you have a specific version. What happens if you have pnpm of a different version? Is that the at least that version?
I was wondering the same thing.
Okay.
I don't know. But we'll probably, one of the things that we will do is start using Renovate Bot to auto bump all kinds of things. And Renovate Bot will auto bump this, and they'll bump, yeah. But long story short is, I don't know. I was wondering a similar thing. Okay, cool. So, I guess the best place to start in terms of actually diving into what makes our monorepo work, is, some of these config files. Here's our base level tsconfig.json. So you don't technically, strictly speaking, need to list all your packages here. However, if you don't, then find references across packages won't work. And this is actually also recommended by the TypeScript docs. So this is what they call a solution tsconfig. No idea why they call it that. But basically you put one of these at the top level of your repo, and point it at all your packages. Now, it's not necessarily a good idea. I'm not sure I'd recommend doing this if you had a big monorepo, because what it does is basically the way TypeScript works is like you open a file from one package, right? You open a TypeScript file from one package, and that will cause the TypeScript server to start paying attention. And it will basically pull in that package, right? It will ingest all the files in that package and like process them and figure everything out, right? And then now if you open a file from another package, it'll pull that in as well. And then, so far it's trying to be fairly memory efficient of only pulling in the packages that you have open, right? Which is nice if you have a monorepo and it's really big. But now you say find references. So then lazily, and if someone who knows TypeScript better than me is either here or watching, please correct me, or if this might change also in the future. But basically, what'll happen then is when you find references or do a rename, right? Because the thing is, by default, each package is going to have its actual dependencies, right? In addition to the solution config, you'll have something here, like for example, Cursorless engine. It has its own tsconfig, and notice it has references, right? So it says, look, hey, TypeScript, I depend on this other package within the monorepo, right? So this is how you start to indicate dependencies between packages in your monorepo. And you basically say, okay, here's this path that I depend on. And so by default, if you open a project, I'm pretty sure what happens is it will also ingest your references. I think. I haven't double checked that specific piece, but basically, I think it'll ingest your references. But it won't ingest things that reference you. Right? So if I'm in common now and I try to say like find references to this thing, pass through IDE base, and it occurs in Cursorless engine, right? It will not have loaded this yet. But when I say find references or do a rename, then what it'll do is it'll start walking up. And when it hits it'll basically walk up your monorepo, and then we'll pull in tsconfig files above you and pull in their references. And so this is why you want this solution tsconfig, so that what'll happen is it'll walk up to the top and it'll say, ooh, okay, bunch of references. And that will actually cause it to pull in the world. And so,
which of course can be detrimental if you have a million files.
Exactly. But I think, and again, I haven't seen this documented anywhere, but I think you could use this to make cool little fire breaks, right? So you can basically say like, look, I want all of these packages, they kind of play nice together. I want renames to work across these different packages. And so I'm going to do a little solution config there, but not at the top level.
Kind of like a monorepo in a monorepo.
Yeah, you can make these little sub. And I will say that my understanding is that WebStorm does this better, because I think they pre-compute references and that kind of thing. And so I think there it tends to be much more efficient to do find references and renames when you're in a big repo, because they've done like caching and pre-computations, so that it just works a lot better for really big repos. This is not based on personal experience, but I've had this suggested to me, so I'll just throw that out there. This is if you're using the like official TypeScript language server, that you have this sort of behavior today, as I've observed. So caveat after caveat, but that was kind of what I found. I needed this in order for find references to work. Now, this is a huge hassle to maintain, and so we actually use a really cool piece of software which is called Meta Updater. And so that basically that is what generates and keeps a lot of our dot files up to date. And it might actually be worth talking about that just because that's where a lot of these things come from. PopDoc meta index, falling air, Drowse. Yeah, what I will say is that we also have this convention we like to use, which we want index files to be basically what are sometimes referred to as barrels. I don't know why, but apparently they're called barrels, where you basically have an index file and all it does is re-export things. Okay, and there is
the question is that if that index file is only importing one thing, do we need it, or should we just rename meta updater to index? I'm kind of split on those two.
Yeah, and so the reason that the reason I personally prefer this approach is that if you do that a lot, which you suggested, Andreas, then you'll end up with a tab bar that just says index.typescript, 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 right? And it makes it really hard to see what you're editing if everything is called index.typescript. And so I prefer that the name of a file is more meaningful.
I think I agree with you, but it creates more files, but it is clearer when you have a tab bar like that.
Yeah, and the other thing is that for when you're trying to open files, VS Code slightly prefers when you do a search, like when you try and use the quick pick, it slightly prefers things to be in the name of the file rather than in the path, the like parent directories, and so it makes it'll get bumped up a bit in the quick pick. So we tend to prefer this even when it's just a single re-export. In addition, we prefer export star to doing specific exports. And the primary reason, on the one hand, one, it's just annoying to have to like keep adding things there. And two, renames break if you don't do an export star. Because if you do like an export blah, comma, blah, comma, blah, then I believe what VS Code or like what the TypeScript server on the rename will do is the rename chain gets broken there, and it will just rename up to there, and then it'll be like, if you try to rename foo to bar, then this file will end up saying rename bar as foo, or export bar as foo. So, and then also you can get to things where you do like a follow, and it'll get caught here. So basically just export star is like a very proper redirect. Yeah.
Just to be sure, or to be clear, an index file can export multiple things.
Yes.
You might have multiple things you want to export from a single, and that's just a way for people that are consuming this API can just refer to the folder name. But you could split your implementations into separate files for convenience.
Yeah, and so this is much more common where you have things like this. And so this is in some sense something else. I mean, yeah, it's the same pattern, but this is less for like trying to, make it so that it's easy to find the name of thing. And this is a way to say, this is the public API of my package. And so this is one of these, like a lot of these desiderata were around that, right? Which is basically, I shouldn't be able to say, hey, look, give me this like /bar thing from the middle of this package. A package should be able to say, look, this is my public API. Don't touch anything else, right? And so that way you can get proper isolation between packages, and they can be very careful and precise about their public API. And so this is basically, there's two ways that you do that, right? One component of that is you use these barrels. And the second component is in your package.json, you use what's called an exports field. Now this is new-ish. It's like Node 16, I believe, introduced this. And so exports, basically it says this is, well, as you can read, it's basically just says, this is the only thing you should be exporting from me, right? And so that means when someone says, right, so when people want to export something from Cursorless engine, pop last, pop next, Drowse. Let's just pick some like random thing from the Cursorless engine, or maybe like from common, let's say, and just find, like certainly, yes, someone's gonna import that. Okay, like reference exotes, Drowse. I don't know if you noticed there was a very slight delay there. That was probably it pulling in the monorepo. So if you look here, okay, so you can see, right, here we're pulling in from Cursorless VS Code core, right? So it was in common, and we're pulling it in from the core VS Code part of Cursorless, right? And now as you notice, we just do an import from @cursorless/comment. As you can see, that's that index barrel, right? And so the point is, anytime I do an import from @cursorless/common, this is where it looks in the package.json for that and figures out what it's allowed to do. Pop.common package. Drowse. So you can see this export says, look, so it's really what exports dot default. That's what we're looking for. If you don't need this fanciness, which is another thing I can talk about, you can actually just say exports : and then this string. That's shorthand, and it's equivalent to exports : dot : default : blah. And so that basically says this is the only thing you are allowed to import from my package. Okay, I think we may end up just pinning and then letting Renovate bot actually do the upgrade. Although for packages that we publish, we'll probably not pin their dependencies because that makes people's lives easier when they import the package. But for packages that we don't publish, then we'll pin, if that makes any sense. Yeah. Okay, fine. So if we look at meta updater, this is what actually defines all of our different dot files, or rather our package.jsons and our tsconfigs in JSON. Now, I think this is a really cool setup. Meta updater is something which pnpm created. It's their own sort of, it's just kind of like a thing they were using internally, and they published it because they're a monorepo, so it's easy for them to just publish everything, right? So this is just some random thing that pnpm publishes. Note this convention, we're using the same convention. You basically @organization name / and then package name. And so we have @cursorless/blah, as you saw, right? Okay, so they do this. So this doesn't mean it's actually part of pnpm, it's just that organization. I think this is a really cool setup because basically there's, so like when you have lots of boilerplate, right, which, you know, we tried to reduce it. We don't have a ton of boilerplate, but, you know, you're going to have some boilerplate. The thing I used to really like the idea of was this thing called plop.js, right? And what that does is it basically you can write these templates to generate things, right? And also at the organization I was at previously, we had these in Python, they're called I forget the name of the thing in Python, but they're like these skeleton template repos that you can use to generate new repos, right? And I loved the idea of it, right? Because I love generality and like consistency, etc. But the problem is they would just rot. And then, so what ended up happening is like it's actually ended up being better. Oops. Okay, we should probably hurry this up. My battery's running out on my. I wonder if I should plug it in somehow. Yeah, so basically what we would do is we'd have these generators and they'd rot, but it turns out that what would happen is actually the best thing to do is to just copy the most recently created package to just clone that, right? And which is kind of annoying. It defeats the purpose of having these generators. And so what this setup is basically, so here's what meta updater does, right? You give it these different files, right? And so this is going to be for every single package in our monorepo, as well as the root. These are these two packages. And what this does is this function will get the input, whatever exists on the directory, in that directory right now, gets to take a look at it, and then it gets to say, and then it updates it and says, this is what it should look like, okay? And so that's basically the core abstraction that it's built on. And so if we falling star urge, crown funk, drowse. The input is what exists today, and then the output is what it should look like. And so as you can see, we do things like, okay, any field that we don't know about, we don't care about. So any file can have its own package.json. Because, for example, in your package, like if we look at the cursorless.org, it's going to have like various different things in its package.json, which are kind of like next specific, I think. It'll have like scripts, which we don't know about. Nothing too crazy. But so the point is we just mirror those through, but the name, for example, needs to start with @cursorless, right? So if it doesn't start with @cursorless, we put that in front of it. And the license has to be MIT. And then the scripts need to include these too, right? And so we basically just say, okay, here's what we mirror through, here's what we force. And so that's the abstraction. Same thing with our tsconfig, right? popdoc meta tsconfig. Listdoc meta void trapspun drowse. Where's the okay, whatever. I don't know why I didn't pick that one out. But so, okay, so here's update tsconfig, and as you can see, we basically just specify what the tsconfig needs to look like, and you can do things like, all right, is there a next config? In which case we need to include next and blah blah blah. Long story short, the point is, look at the input, decide what we want this file to look like, and then spit it out. Okay, that's the abstraction. Now we can use that for three things, right? The first thing that we use it for is what it looks like we're doing, which is like, I actually want to update something, right? So let's say we want to change our license from MIT to like Apache or something. You just update this one file and you say pnpm meta updater, and it'll go and update all of your package.jsons, okay? That's one thing that it does. The second thing that it does is in CI, we run it in check mode, where it kind of works a bit like precommit does, if anyone has used the Python package called precommit, where it runs your fixers, and if anything changed, that's an error, right? And so that's what it does, right? So it basically says, look, I'm going to run these fixers, and well, if the license field changed, then, well, the license field is messed up in that package, I'm throwing an error, right? Or if the compile script got messed up, etc., right? So we actually force that the fields that we care about are completely consistent across all our packages in CI, okay? And now the third thing that does is, now let's say I'm scaffolding out a new package. Well, what I can do is I can basically just put the 2 or 3 fields that are absolutely necessary, like what's the name of the package. I don't even need to put the @cursorless in front of it. I just say I call it foo, right? And then I put a description in, right? So we raise an error if there's no description found, right? So you put those 2 fields in a package.json in a directory. And then you just say pnpm meta updater, and that will scaffold out the rest of it, right? So if it doesn't find a tsconfig, that's fine. It'll just make it and put the right things in there. It'll put the right things in your package.json, and it is now functions as your an equivalent of a plop file, which is like, or one of these like template generators, but has to be up to date. That's the beauty of it, right? Because if you start doing things differently, CI is going to complain, right? So you have to keep this thing up to date. So I think it's like a really beautiful and powerful way to solve 3 tasks, right? Like, I want to be able to quickly update a bunch of files. I want to quickly scaffold out a new package, and I want to make sure that things are consistent across projects, all solved with this one little package. So yeah, I very cool. Like, I would imagine you could probably build your own meta updater package, whatever it is we're importing. Can't be much, but it's just a really cool idea. And so I guess the thing that originally got me onto talking about this was, I mentioned that thing at the root is the solution tsconfig is annoying. Well, actually, it's generated, and if you add a new package, you just rerun the meta updater, because what it does is it reads in the pnpm lock file, which includes all of your where's our log file? There we go. You can see it. You have to do an install first, yeah. But basically, your log file, basically, okay, here's the root, right? And then here's cheat packages / cheat packages / cheat logo, blah, 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 blah. And you can see so we just pull those in, and we automatically are going to pop last. Drowse. Oh, there's nothing behind it. Where did it go? I had it open. Yeah, for some reason when you click in here, it seems to like clobber it. So long story short, we generate that file, right? That tsconfig. So right, so we don't actually have to do this. How do dependencies work in the monorepo, right? How do you indicate that one thing should depend on another? Well, it's fairly easy. You basically just, from within the directory, you just say pnpm add and then the name of the other package, right? So low show. Drowse. So like I can just like list packages here, right? So let's say I cd into packages / like cheat sheet, and now I'm here. And if I wanted to make it so that packages.cheat sheet depends on common, right? I would just say, I'm not going to do this, but I would just say that. Done. Now I can. So what does that do? So it does a couple things, right? So the one thing that it does is you look at the package.json, low show, low dog, drowse. So you can see if we look here, dependencies in package.json, it's this fancy thing called workspace:***. And that basically says just like, don't worry about the version number. That's what the :* means. And only pull it from the workspace. Okay. So it just says, look, this at cursorless/common, find one of the packages in your workspace. Oh yeah, I missed one teeny little very important file. This is how you tell pnpm where it can find your packages. So notice this whole like package, the fact that all our packages are under packages, it's our own decision. Like that's just easier for us. We may at some point move into a world where we put packages in other places. Like our deploy things are not really packages, right? Like our website isn't really, in some sense, a package. We're not deploying it, but it has a package.json. So like we don't really care, and it's easier to just have them all in one place. But we could say like, oh, I want apps and libs, or apps and packages, or like I want to be able to put them. If you check out the pnpm, so pnpm itself is obviously a pnpm monorepo, and if you check that out, I mean they have packages everywhere. They must have like packages in like 90 packages in every directory. I mean, it's so you could get a lot crazier than this. They've applied the npm ecosystem philosophy to their own repo, and I would still potentially want to go package/star for that, but I guess there are benefits to be able to say like, look, package is a fairly generic term, etc. All right, the point is, in our world, pnpm will only look for packages in star. You can also do star if you want to be able to nest. We don't, but yeah. So the point is, if we look in Cursorless engine, you can see at Cursorless/common should come in the workspace. And the second thing that it does is in the node modules from Cursorless engine, it inserts something, right, at Cursorless/common. This is actually just a symlink to the Cursorless common directory. Low show. Drowse. So if we cd / cursorless engine, yeah, exactly. So so as you can see, within node modules, right, I mentioned that everything here is a symlink to this like root level storage. That's what all these symlinks are. And you can see here, if we look in the at Cursorless subdirectory, right, common, literally just a symlink to the common directory. Which is kind of interesting, right? So it's just all these little, so it makes it so that there's like, basically we have this very strong isolation between our packages, but you can very precisely create named wormholes effectively, right, from via node modules to go from one package to another. And the cool thing is when you publish and those get published as separate packages, a translation step will happen. Apparently, we haven't done this before. We haven't published anything yet. We will publish the Cursorless engine, so anyone could just import it wherever they want. But it will then translate this into a proper, just like, look, I'm just going to grab the version when I publish, and then so that way when you install, it'll become a totally normal relationship. They're not part of any special monorepo relationship. So yeah, kind of neat. I think that you create these little wormholes via symlinks in your node modules, but otherwise you have complete isolation. Now, the next thing is you need to tell Typescript about the difference, right? Because Typescript, okay. So Typescript will actually use autocomplete. So I believe even without this, autocomplete will work now between the two modules, right? So when I'm in engine, I can import things from common because now it's in the node modules, right? Remember, and node modules are how Typescript does autocomplete. But you are supposed to tell Typescript about these references. I haven't totally convinced myself that it's necessary, but I believe what it does. So one thing that it does do is that when you do, so the Typescript compiler has a new flag called --build. And when you run with --build mode, what that will do is it will actually look at these references and make sure that they're built before the package itself is built, right? That's sort of the primary thing that references does. If you're not actually doing compilation and you're running in VS Code, I'm not sure if it works with just the TS server out of the box. I think you need to be in VS Code. It does some sort of in-memory stuff to just go directly to the source file, so you don't need to compile and do declaration maps and stuff like that. But basically, otherwise what'll happen is like you'll compile and then these declaration maps will appear to map from the declaration. It's sort of like a source map, but it maps from like the output TypeScript declarations to the places that they came from so that you can do jump to definition and find references. So notice now there's two places, right? You need to have in your package.json, you need to say, look, this is what I depend on. And then in addition, in your tsconfig, you need to say what you depend on. But of course, we use meta updater to ensure there's just a single source of truth. So basically what happens is when you run meta updater, it looks at the log file, finds local references, and updates the references here, right? So when you run it in update, so basically if you would do pnpm add, and then the next thing you would do is basically say like pnpm meta updater. And of course, if you forget to do that, CI is going to complain at you. And yeah, this file is generated. This is like the absolute minimum of what you need. Everything we could, we hoisted into the base, which basically all of these extend. Again, the extends file. So this is completely automatically generated. So if you want, you can add compiler options. But for simple things, we don't. And you have to, these are always, so all paths are going to be relative to the tsconfig in which they are written. And so you kind of need these to be here in order for this stuff to work. So anything, and these things as well, and the references you can package specific. Everything else goes into the tsconfig base. And so I mentioned, so references is one of the fields. Falling bat. Drowse. Oh yeah, I wonder, we should fix that. We have a couple of these unknown URI scheme things. We should think about what to do about those. So, but these are our compiler options, which everyone derives from. This is this composite thing. And what this tells TypeScript is like, because if you don't do composite, then it's not really TypeScript doesn't do any separation. It's basically, yeah, I can import that, you can import that. There's no separation between packages. And what composite does is basically says, look, I'm not going to try to drill up the chain and then try and drill into another package if I can't find it via the node module's wormhole. It's like basically just like stay in your zone and only use your node modules and your things and your references. Don't do anything else, right? And so that's what composite does, is it actually gives you proper monorepo isolation. That's my understanding. So that's sort of the biggest field here. The rest of them, you have to have declaration maps if you're in a monorepo. The rest of them are less interesting, although infuriating sometimes. The module resolution stuff is just an absolute nightmare. I'm not going to talk about it because I don't like it. It gives me nightmares, but we got something that works. I mean, long story short, node next. If you don't use node next, then TypeScript won't respect the exports field of your package.json. That's what next means, because it's a relatively new node thing. Module detection forces TypeScript to treat everything as a module. It doesn't always seem to work, but it seems to work okay for us. And then this is the output module format. One thing I would recommend trying your best to never have to have TypeScript output JavaScript. You may not get there. We didn't get there with Cursorless. Andreas got there with one of his smaller repos. But it is nice because if you do end up having like output, like having to rely on the outputs of well, first of all, TypeScript is slow. And second of all, you get into weird things where it's like, okay, if I try and access the directory name to try and find some sort of asset, well, if it's moved to a separate directory, that's the relative path that I want rather than the relative path of the actual source file. So, but you're editing the source file, but it's going to be resolved relative to the generated file, right? So like if you can get away with it, I would definitely recommend avoiding having to use the actual output files. But so using something like a bundler is how you can do that, right? So for example, with the Cursorless VSCode extension, we just use a bundler that bundles up the extension into an extension.js single file. ESBuild is lightning fast. It takes 100 milliseconds to bundle the entire Cursorless code base. And so we basically stopped doing type checking before you try to run your extension because it was so slow. And now our extension is just instant when you try and do local development. Yes, TSX is really cool. So basically it uses ESBuild behind the scenes. So it's a way to run a TypeScript file directly. So if you can see, we have various different scripts. It just transpiles it into a single file, rolls it up using ESBuild, and then it actually goes and does and then runs that single file. So you just say TSX, no relation to the file extension, and then pass it a TypeScript script, right? And so now here's a little monorepo gotcha, and I think I may end on this because I think we've done a pretty good amount of time. So One gotcha with a monorepo, and this is the reason I brought this up is, well, actually no, Andreas, you told me to bring it up, but it is very related to the note. Maybe this is why you mentioned to bring it up, which is that it is very related to this notion of not trying to compile. On the one hand, you're just running it directly at this, and if you are not in a monorepo, this just works, and you're really happy. If you are in a monorepo, the problem is that now, let's say this imports something from, like this imports from common, as it does. For sure, this definitely imports from common. The problem is if you look at the package.json for common, okay, and this loops back to something I mentioned I would come back to, and it turns out I did. Low dog. If you look at this, these exports here, right, you can see this is the default. I mentioned that we had this random thing here, Cursorless bundler. So now what this is basically you can give Node custom conditions, okay? And so by default, it will be going directly to the index.js. And the reason that we do that is because if you're publishing a package, it's just considered good practice. Like this is the package.json. People should be going to the JavaScript. That tends, although I do wonder if we should start moving to a world where people go directly to TypeScript, but that's a whole nother question. But if this condition is set by the when you're doing resolution, this is where it will go instead. And so what that allows you to do is basically, so if you don't do that, then basically now let's say, all right, I'm trying to run TSX to run one of my scripts, and it refers to something in Cursorless common, and I haven't done compilation, TypeScript compilation, this file won't exist, right? So it basically means I create these weird build dependencies where, like, before I even run a script, I have to do TypeScript compilation. Things get slower, etc. So what I do instead is we have this Cursorless bundler condition that says actually just go straight to the source file. And so then what'll happen is when I run that script here, this thing will import Cursorless core, right? So we just set this condition. It's a flag to TSX. It's also a flag to ESBuild. You set this condition, and instead it will go straight to the source, right? And so this means that we can run the script without ever compiling anything. You pull up the repo, you're bootstrapping, lightning fast. You don't have to do any TypeScript compilation. You can run whatever script you want, and they just work. You don't need to worry about that. So another reason to use this condition is we noticed there was like a large increase in our bundle size when we bundled up the Cursorless extension into a JavaScript before publishing. It went from like 600-ish K to like 850K. And I could not for the life of me figure out why. Well, it turns out what happens is if you don't, we split up into monorepo, and before we had the like entry point index extension.typescript pulls everything from our monorepo, TypeScript to TypeScript to TypeScript to TypeScript, rolls it up. The problem is when you move to a monorepo, if you don't put this thing, it sees that package.json and it says, hey, I'm going to go to the JavaScript. And for whatever reason, tree shaking, various module shims, who knows what it is? Someone knows what it is. It's not me. It just blows out the bundle size, right? Because it's trying to bundle up the output, something that's already been through a processor. So instead, if you use a condition like this to go straight to the source, you end up with a much smaller file size. That's why I think maybe you actually want the entry points should be TypeScript, right? In some day, right? Like maybe that would be better, because then everything goes to TypeScript, and we would end up with much smaller modules. Maybe you could have like a condition that everyone agrees upon, which says, look, go straight to the source, right? And then if you just pass that in, then you get it. You just you know what you're doing. You opt into it. But until some standard exists like that, it's considered good practice to namespace your conditions, because otherwise, right, this condition is getting applied to everything we pull in. So, right, if some third party uses the bundler condition in some totally different way, things could break, right? So you are supposed to prefix your conditions. Okay. My voice is getting tired. I should probably go get some dinner. You guys are probably getting tired. So any questions before I turn off the mic? Let's make sure it didn't turn off. Okay, still recording. Cool. Yeah. Okay. Again, either it made no sense or it made lots of sense. If there's no questions, go to the repo, go check out the sources, and then come ask questions on Slack if you're still curious. Because I think the source code itself is the best way. Pull it down, clone the repo, start making changes to it, install packages, play with it, see if you like the DX, try doing renames, stuff like that, and just see how the DX works. Try running the scripts, etc., etc. But we're so far pretty happy with it. It's only 3 weeks old-ish, so it's still fairly new, but we're pretty happy with it. And it'll enable us to do some really cool stuff, like basically bundling the Cursorless engine directly into the web page, and so you can play with it online, and being able to use Cursorless in other editors, even embedding Cursorless directly into Talon, so you can use OCR to put hats on everything on your screen. All kinds of stuff are enabled by making this really clean separation where we can extract out the core Cursorless logic, put it in a package, and then import it everywhere, and make sure we don't break things because it's a monorepo. We auto check everything that it gets imported into, and publish from CI as well. Each individual package ends up being quite clean, and the nice thing is the stuff that is hard actually is generated for you. But yeah, there's really not much extra. One note, I can't help myself. There's the reason we actually have a source directory in everything. We originally didn't. If you don't, then it means, let's say you try and do an internal import from here to here or something like that, or from like here to here basically, then if you don't have a source directory, it's going to hit this root here, and then it'll read that package.json, and now it's trying to resolve modules using package.json, which is the external facing one. So you can accidentally hit the JavaScript version, etc. So it's better if each package, all the source files in that package are in one directory, so that they don't drill all the way back to package.json, so they can just behave very much like their own little repo, their own little package. So all these relative imports, you can see we do imports, we wormhole out using these different things to get elsewhere, but from within here we use relative imports. Well, yeah, I think that's all. Thank you so much if you made it this far. Thank you so much for watching, and yeah, happy coding.